Back. We're doing the second part of 6.10. And so the directions were draw a picture, solve it, write an equation, then solve that equation. So my directions for you are pretty much the same, except for label and find that right triangle. Because if you could do that, then you're pretty much done. So it says a hot air balloon that is 600 feet above where it is planning to land and descend at a rate of 40 feet per minute. Sarah is driving over rough terrain at a speed of 10 miles per hour to meet the balloon when it lands. If the angle of elevation to the balloon is 20 degrees, how far away is Sarah from the place where the balloon will land? And who arrives at the landing spot first? Okay, so this one's quite a bit here. So I'm going to draw a picture first. So here's my hot air balloon. So here's my hot air balloon. Okay, looks like a light bulb. Get over it. Maybe if I did like this. Yep, that now doesn't look like a hot air balloon. Oh well. Okay, it's 600 feet above where it is planning to land. Okay, it's 600 feet above where it is planning to land. So this is 600 feet here, right? And then it says, and it will descend at a rate of 40 feet per minute. So can you imagine that it's going to go straight down? It's not like a plane. It doesn't what is it called? It doesn't go at an angle. It's going to go straight down. So Sarah is driving over rough terrain at a speed of 10 miles per hour to meet the balloon. So here's Sarah over here, maybe. And she's going this way. So I'm going to write their speeds in a different color. So she's going 10 miles per hour. And the balloon is descending at 40 feet per minute. So it's going down at 40 feet per minute. Okay, they're already messing with you because you got so many different units of measure, right? So make sure that you bring everybody to the same unit. Otherwise, it's going to give you an answer and that answer is going to be wrong. Okay. And then it says if the angle of elevation is 20 degrees, so that guy right there is going to be 20 degrees. How far away is Sarah from the place the balloon will land? And so I'm looking for this side here, X. Okay. So, and then they want to know who arrives first. So looking at this picture here, I don't really need to do any conversions yet because that's going to be for the second question. All I need to know is that. So according to this, I like to draw here. I write, they gave me the opposite, and then they gave me this side, which is my adjacent. And then I go like this. So ka toa. I didn't spell ka right. There you go. And so they gave me they gave me opposite and adjacent. So which one of those ratios? What does that say in the middle? Sorry. Which ratio did they is going to be best for me to help find this distance? And because they gave me opposite and adjacent, then it's going to be tangent. So I'm going to go with tangent of 20 degrees equals to the opposite, which is 600 feet, divided by x. And I don't know what x is. Okay, so I'm going to look for it. So whenever I'm solving these and x is on the bottom, there's a couple different ways that you can solve it. I usually think to multiply by the denominator. Right? And then divide by tangent 20. right? So x is equal to 600 feet divided by tangent 20. And some of you are like, Miss Johnson, you can divide by tangent 20. Yes, it's just a number. Don't treat them any differently, right? So I'm going to go in here and go 600 divided by tangent of 20. And I get 1,648.5 feet. Okay, so I'll just go with 1,648 feet. About 1,648 feet. And I'll put that here because I like to look at it and say, oh, that triangle makes sense, or it doesn't, right? So yeah, that triangle makes sense. If it's 600 feet above air, 1,648 could be it because that angle is very small. That makes sense to me. So we answered the first question, 1,648 feet. So now, now what I need to do is figure out who's going to get there first. Okay. And so there's a lot of units of measure that need to be converted. So either I'm going to convert 40 feet per minute to miles per hour, or I'm going to convert miles per hour to feet per minute. And so I'm going to convert miles per hour to feet per minute because that makes more sense to me. Okay. Because it seems like it's going to be like a otherwise it's going to be a lot of decimals. And I find it easier to deal with I'd rather deal with big numbers. So I need to convert 10 miles per hour to feet per minute. So whenever I'm doing conversions, and this is sometimes called dimensional analysis, I go like this. I go 10 miles per hour. Miles is on the top, hours is on the bottom. I'm going to multiply this by something. Now I want my answer to be in feet per minute. So my answer, I want it to be in feet on the top and minutes on the bottom. So because I don't want hours, I'm going to put hours on top so they will cancel out. And I shouldn't have put that one there, but I know what I'm going to do next, so that's why I did that. Right? And then I want to convert it to minutes, so I'm going to put minutes on the bottom. And then I ask myself how many hours in a minute or how many minutes are an hour, and I put 60 minutes in 1 hour. So now I already have my minutes in my answer in there. So the next thing I'm going to do is I'm going to try to get rid of my miles and get it to feet. So I want feet, so I put him on top, and I want to get rid of miles, so I'm going to divide out by miles so that they will cancel as well. And then I just ask myself how many feet in a mile or how many miles in a feet. And I put 5,280 feet. I just looked that up in 1 mile. And then now I have everything that I want. I have feet where I want feet to be, and I have minutes where I want minutes to be. So now I'm just going to multiply and then divide. So then my answer is going to be 5,280 times 10. I didn't have to do that, but let's just continue, is 880. So Sarah is traveling 880 feet per minute. And she better be traveling faster if she wants to beat the balloon there, because the balloon has less things. So she's traveling 880 feet per minute, right? So how many minutes is that going to take her if she has to travel 1,648 feet, right? So then you'd have to divide that out, right? So let's see. If it 1,648 divided by 880 is 1.9 minutes. So it's going to take Sarah. So let's write some math on that. Let me put it over here. So Sarah has to travel 1,648 feet divided by 880 feet per minute. is going to be 1.9 minutes. This is Sarah. Okay. Oops, with an H. Okay. Same thing goes for the balloon. The balloon has 600 feet. So the balloon's going to have to travel 600 feet divided by 40 feet per minute. So then let's divide that out. And it looks like the balloon is going to lose. Yep. The balloon lost 15 minutes. I don't think they were racing. So Sarah, because it only takes her 1.9 minutes. Okay. If this problem did not make sense, it had a lot of layers to it. So just go back and figure out, well, could I have found that 1,648 feet? Yeah, most of you're going to be able to do that. Now, with the rates and stuff, the dimensional analysis really helps me really understand what we're doing. And then now you're just dividing, right? Like if you have to cover 1,648 feet and every minute you're covering 880 feet, it's only going to take you about 2 minutes to get there, right? Okay, let's do another. It says an airplane is descending as it approaches the airport. If the angle of depression from the plane to the ground is 7 degrees and the plane is 6,000 feet above ground, how far is the plane from the airport? So you should be able to be good on this now in terms of drawing a picture. So go ahead and do this problem and then come back to me and let's check our answers together. Okay, now that you're back, here's my picture. So here's my plane. Miss Johnson, she's such a great drawer. Looks like kind of like a person. Okay, he's 6,000 feet above ground. The angle of depression is 7 degrees, which you know now is the same as the angle of elevation. It says, how far is the plane from the airport? Now, whenever you're talking about how far something is, we're usually going to go with the distance, the horizontal distance, okay? So that's going to be my x. And then, so now you should see they gave you the opposite and the adjacent side, right? So I'm going to look for which one, so ka or toa, which one is it? And it's going to be toa. So then that's the tangent of 7 degrees equals to 6,000 feet divided by x. And we just did a problem like this. So you should be okay with solving this. So then I'm going to multiply both sides by x and then divide by tan 7. I'm going to do them at the same time because those are interchangeable. So then I get x is equal to 6,000 feet divided by tangent of 7. And then whatever that is, that's my answer. Let's see. So we get 6,000 divided by tangent of 7. Again, checking to make sure I'm still in degree mode. So I got 48,866. 48,866 feet. 48,000, what did I say? 866 feet. And that seems doable, right? If it's 6,000 feet in the air, it's probably really, you probably need a lot of distance if you're only going down at a degree of 7 degrees. You don't want to go down too much. Might get people like really, sick. I'd probably convert that to miles just because no one ever says I'm 48,866 feet away from you. They really would talk about in miles. But I'm just going to leave it right there. And the last problem we're going to do is Michelle is 60 feet away from the building. The angle of elevation to the top of the building is 41 degrees. So here's Michelle. She's 60 feet away from a building. Here's the building. The angle of elevation is 41 degrees. How tall is the building? So we're going to look for that. And then here, they gave you the opposite and they gave you the adjacent. So yeah, some of you are like, oh, I get this, Miss Johnson. It's tangent of 41 degrees is equal to y over 60 feet, which it's 60 tan 41 degrees equals to y. And so that on my calculator is 52.2 degrees. Oh, 52.2 feet, sorry. Is about 52.2 feet. Okay. So again, whenever you're doing these problems, the biggest thing that you want to do is draw your picture. And then find the right triangle in that picture and then figure out which ratio you're going to use. Sine, cosine, tangent. Which one are you using? And then once you have that down, then you can solve that equation. And solving the equation, it looks very intimidating because you have all these like tangents or sines, but really you're just using SADMAP like we've been doing from the beginning of this school year. Okay. So thank you for listening.